Mr. Thibault Minaj, Vice President Caribbean Hydrogen de France and his team, representatives of the International Finance Corporation, IFC, representatives of Rubis Caribbean, representatives of Stantec Caribbean, members of the St. Philip community, members of the press, guests online, ladies and gentlemen. Welcome to the public consultation for the proposed development of a solar photovoltaic energy facility at Harrow Plantation, St. Philip. My name is Joyanne Haig. I am the CEO of Haig Communications, the company associated with this project. Now, most of you would have seen Stantec over the last couple of months visiting the area, and members from my team as it relates to some community engagement. This has now led us to this evening's proceedings, as we now invite you to listen to the findings of the Environmental Social Impact Assessment. This is a study that is required by town planning, and we are here this evening to share those findings with you as it relates to this project. We have highly qualified engineers on team, an independent team of engineers led by Stantec Caribbean. I will now hand you over to this evening's moderator, Mr. Ziggy Marshall, consultant with Haig Communications. Ziggy.
Thank you very much, Joyanne. Welcome to this evening's activity. I have the pleasure of introducing you to our panel. And I'm going to start with Mr. Thibault Minaj, Vice President, Caribbean, and Thibault Minaj, Vice President of Hydrogen de France, Mr. Justin Jennings-Ray, who is the Environmental Engineer from Stantec Caribbean. To my immediate right is Miss Janice Cumberbatch, the sociologist. To my left, Mr. Andy Gill, who is the Town Planning Consultant at Richard Gill and Associates Limited. He's the Planning Designer, Consultant, and Planning Agent for the project. Mr. William Bain, who is the Town Planning Consultant, Bain Planning and Development. He's engaged to undertake the Agricultural Impact Assessment component of the EIA. And online, we have Mr. Gregory Cooks, who is the Air and Noise Specialist from Stantec Canada. So that is our panel, or members who are and which are Miss Jackie Beckles and Mr. Leo Theron. And I'm going to hand you over. We're going to watch a quick video, and following to the video, I'm going to hand you over to Mr. Minaj, who will do a short PowerPoint presentation. So thank you. 90% of the electricity is generated with imported fossil fuels. What this means is that traditional fossil fuel power plants have to be replaced by renewable energy such as biomass, wind, and solar. Renewable energy produces carbon-free electricity and saves fuel imports. But wind turbines only produce power when the wind is blowing fast enough, and solar panels only produce power when the sun is shining. They are intermittent sources of energy. In an isolated electrical grid, such as an island, if too many intermittent sources of energy are implemented, the existing electrical grid becomes unstable, eventually leading to risk of a blackout. But what if we could produce clean and stable electricity 24/7? The Renew Stable Power Plant, developed by HDF, is a combination of utilizing a renewable source of energy in tandem with a long-term energy storage based on clean hydrogen technology. The energy storage is filled during the day and delivers electricity during the night, allowing the Renew Stable Power Plant to generate clean, stable, and reliable electricity 24/7. Located in St. Philip, Renew Stable Barbados is a large energy project designed to cater to the local energy needs. Renew Stable Barbados will facilitate 8% of the country with competitive, clean, resilient, and stable electricity. It will provide continuous power 24 hours a day and satisfy end-of-day peak power demand for more than 20 years. Renew Stable Barbados is non-intermittent and clean. It is a significant step towards a renewable, stable, and independent power supply for future Barbados.
Good evening, everyone. So my name is Thibaut Ménage. I'm the Vice President for the Caribbean for HDF, which has a year ago implemented a local subsidiary, which is called HDF Caribbean, which is employing some people actually in the room tonight and looking at not only developing this project, but developing also other projects in the region, in the Caribbean region, operating from Barbados. The RSB project that was briefly presented on this video is a bit more complex than a simple solar plant, and this is why I would just take the time to explain the project before we go into the findings of the environmental and social impact assessment that has been performed by the independent consultant Stantec. So the ownership of this project at the moment, which is under development, is shared between HDF and Rubis Caribbean Holdings, which I'm sure everybody is familiar with. So HDF is developing the project and owns 49%, where Rubis is the majority shareholder with 51% of the project. That being said, HDF Energy will sell down some of its share if we get to the construction of the project to local investors, especially related to the credit union movement that we are having discussion with at the moment. So the forcing structure would be 51% Rubis, 19% HDF, and 30% local with the credit unions. So what is this project about? It's first of all, it's a large solar plant, 50 megawatts. So I don't know if that speaks to everyone here, but 50 megawatts is actually 5 times the size of the project that is in St. Lucie, Trans, operating by BLPC. But it's not only a 50 megawatt solar. It's also a large-scale storage of power, which is a combination of a hydrogen storage and a battery storage. So 3/4 of it is hydrogen storage, and 1/4 of it would be a battery storage. Battery storage is a good short-term storage. Hydrogen storage is a good long-term storage. So they work complementary with each other, and this is the most competitive setup in order to deliver what the RSB project has been designed for, which is a continuous power 24/7, thanks to the sun as the primary source of energy. And it's also a major investment for the country, which is around $150 million US, so 300 million Barbados dollar, which will be financed by international and local equity and debt. So how does this plant work? There's the large PV plant produces power during the day, and basically this power is being stored in the form of hydrogen and a little bit in the batteries as well. Batteries are short-term storage, as I said before, and the hydrogen is long-term storage. So I think battery and solar are well known now in Barbados. The new elements to this project is the hydrogen side of it. So it deserves a little bit of an explanation. Hydrogen can do a lot of things, but it can store large quantity of electricity for a long time. And you can actually transform water into hydrogen with electricity based on the electrolyzer technology. You can store it during the day, so you produce a lot of power during the day with the sun. You store it during the day into large tanks, which are standard tanks at low pressure. And this hydrogen then is being reused during the night, going through what we call fuel cells. And fuel cells is the same as an electrolyzer, but it's the opposite chemical reaction. So it reproduces water and uses the hydrogen to reproduce electricity. And so the goal of this is to displace a lot of power being produced during the day to the night when it's needed, actually, because solar doesn't produce during the day. So we're going into a bit more details now, and I will try not to lose you there. This is the typical solar production in Barbados. Actually, this is real data coming from Bushy Park, where RSB project has installed a solar meteor station, measuring real-time solar data. So you can see so this is the power, and this is the time over one day. You can see that at 8 a.m., the solar started producing power. It doesn't produce anything during the night. And then you see the production is very unstable, because whenever the clouds come over, the production drops. The clouds come out, the production comes up again. And around 5 p.m., next to the sunset time, there's no more production. So Barbados right now has a lot of it, because you saw solar plants all across the island. It's almost 10% of the production of the island. But the grid of Barbados has the responsibility and the duty to deliver power all the time to everyone, not only during the day. What Barbados actually produces and need to meet as a demand looks more like this. You see there's more production during the day. There's more production needed during the day because there's AC turning on. And production needed also during what we call the end of the day peak. And this is when people come home and they plug their device, washing machine, television, and so on. So that boosts a little bit the need. You can see in this part, solar doesn't produce anything. So solar cannot help this side. And there's still a night load that the solar is never going to cover. So what the RSB project does is that it produces a lot of that, but it treats this with a lot of storage in order to deliver something that is stable, 24/7, with 2 levels of production. And those 2 levels of production are actually matching the biggest demand of Barbados. So it really delivers power at the most critical time, and it helps the utility stabilizing the grid, because this project can deliver power as well when needed. Those things can be displaced a little bit according to what Barbados Light and Power Company needs in order to keep the service stable for everyone. So how does this project look? It's actually a big solar plant, as I said. And in the middle, there's the storage. So all the power that's going to be produced during the day in this area is going to flow to the storage, which is located in the middle. So there's a bit of a 3D effect there, but it's really in the middle that it's located. So in this middle, there's going to be hydrogen tanks, fuel cells, batteries, water storage, equipment, electrical equipment. So it's going to be monitored 24/7, and this is where the power is going to come out clean and stable to the grid. You can see as well we have little holes, which are ponds, natural ponds that we have by design kept in order to mitigate some effect that would be discussed after. There's also up there a sheep farm that we will just discuss now. So where is it located? It's close by, of course, that's why we're here, in St. Philip. It's north of 6th Road, and it's actually southwest of Bushy Park. So we can't see the roads here, because the 3D didn't do the road, but basically, the sheep farm is next to Bushy Park, and the solar array is next to 6th Road. So what about this land? What about the land usage? We're talking here about 183 acres of land in Howrah Plantation. And this land will be kept in agriculture with a dual use of the land. Not only it will serve the policy of Barbados when it comes to replacing the power assets of the country with renewable energy, a stable one in this case, but also it serves the food security policy, following the guidelines of the Ministry of Agriculture with the solar grazing policy that has been developed by the Ministry of Agriculture. So this project would be the largest black belly sheep farm on island as well. It would host the largest black belly sheep farm on island. So it's designed for a maximum capacity of 1,800 heads. And it's not only a farm that we're developing there, it's a model that would actually boost the industry of the black belly sheep. The goal of this project here, and we are putting resources on the table for this, there's two consultants, one from overseas and one from here, that are working on the agricultural model of this farm, is to have a sustainable farm operation for 25 years. So make sure the sheep are happy, they're doing good meat, which is one of the revenue streamline, but also the revenue streamline will come from manure and from skin. We are also looking at application. The consultants are looking at product from milk as well, but this is down the line. So the project would help this farm because it will finance the facility for the sheep pens, and the utility for it, and give access to the land. But not only that, the sheep are good at maintaining the site. And this is demonstrated with the plant from BLPC at Trends, where they graze all around the panels and maintain the site quite efficiently. So what are the benefits of this project? First of all, it allows to decommission some of the old power plants that needs to be decommissioned. Barbados Light and Power Company has some old power plants that they need to decommission. And as I said before, intermittent plants, such as a solar plant, cannot help this decommissioning because you cannot decide when the solar is going to produce. So this project produces on-demand power, which allows for decommissioning of those assets and not having to reinvest into new assets. So that saves costs as well. It stabilizes the grid because we can call the BLPC can call this plant when needed to stabilize the grid. It also stabilizes the prices of electricity because this project is a big investment at the beginning, but then you don't have to purchase any fuel or any commodity for 25 years. Everything is set for 25 years. So that acts as an edge against rising fuel prices. And of course, it avoids some investment on the grid because this is an investment. So it actually allows to completely decommission a gas turbine. In terms of numbers, this will produce 56 gigawatt hour per year. I don't think it speaks to anyone except if you work in the energy sector. 56 gigawatt hour is 6 to 7% of the consumption of Barbados yearly, right? So right now, Barbados is at 10% renewable energy based on solar, tiny bit of wind, and we'll jump with this project potentially to 16 to 17% without introducing any problems. I said solar at some point creates some troubles. This is not creating any troubles. In terms of, it actually saves some foreign exchange because we don't, like Barbados Light and Power would have to buy less fuel and less be exposed to it. So that's actually more right now because it has increased, but more than 15 million Barbados dollar per year that is being saved in fuel imports. And it will, as I said, represent twice the solar power that is already on island with one project. So just double the existing capacity and multiply by 6 the actual the actual storage capacity, which needs more at the moment on the island. It's also related to environmental benefits locally. 45,000 tons of CO2, which you know are related to greenhouse climate-related greenhouse gases, basically. And just so you understand, a Paris-New York return trip in economy class, of course, is 1 ton of CO2. And it will also be the first green hydrogen infrastructure on island. Even so, hydrogen is being used all across the globe right now. This is new to the island, especially as it's produced from renewable energy. And that will allow other projects to be developed because the hydrogen is being used for other use, such as heavy trucks mobility, for example. But what about jobs? Because this is something that the community has responded when we did the social survey. A lot of people in the community were asking about jobs, which is actually a very good point. So right now, the RSB project already employs, through the developer, already employs around 5 people in Ireland, plus give job opportunity to a lot of the existing consultants. Some of them are in the room. So 5 people are already dedicated to this project full-time, and other people from overseas are working on it, but we're not counting overseas jobs, right? Just local jobs. But it's actually set to increase a lot because on the construction site, for 2 years, because it's going to be 2 years of construction, we expect 120 jobs to be created for this period. So this is the most job-intensive time of the project. Locally, it's going to be a lot of site preparation, civil engineering, electrical engineering, mechanical engineering, security, and so on. Moving parts from an island to the other side of the island. And then after that, when the project is built, there's operation-related jobs, which are less, but for a way longer time. So we expect 10 jobs to be created. Some are related to monitoring the site. Some are related to the agricultural part of it. This is an estimation right now, which is quite conservative. This can go up with the sheep farm as the operation ramps up. And those are direct jobs, but then the entire value chain of the sheep farm will employ more people as well. And this project will allow other projects to be developed as well. So more jobs in construction, more jobs in development, more permanent jobs as well. So how these jobs really benefits the community. First, we proposed the job first when qualified to Six Road and Padmore Village, which are the surrounding communities. We have actually a real example of that we already did. So project manager Jacqueline Beckles here from HDF has led the installation of the solar material station that gave the graph that you saw before. This has been installed and is now being maintained by people from Six Road. So it's a small job for now, but still, this is really something we dedicated to. There's also indirect local jobs that would be opportunities for catering, for people that are working on site, people that are building the site. So there's going to be activities that could flourish around that. And this is harder to quantify, but there's potential jobs as well related to the attractiveness of the site. Just so you know, this site, on the northern boundary of the site, there's a old train line that is going to become a cycling line, and there will be an educational stop for the project in order to explain what it is about, everything that I'm doing right now, basically, and a sheep farm, and that is likely to create attractiveness and little jobs next to this road. But maybe we can do more with that. This is something that is hard to evaluate right now. So yeah, that was just the explanation. The real content of this presentation is the finding of the ESIA, but because this project is a bit more complex, I wanted to give you a brief overview of what we're talking about here. You can reach out to us. There's a WhatsApp line for the project that you see here that is managed by A-Communication. There's an Instagram that we created that will have some pictures uploaded in the upcoming weeks, starting with this meeting. And there's a website that is being always uploaded with the latest news and re-explains all the project as well, which is renewstablebarbados.com. So just as a reminder, renewable and stable at the same time. So Renew Stable Barbados. So that's it for me, and I will pass on to Justin. Thanks a lot.
Thank you so much, Thibault. Nice overview of the project. Just to hit some key points: large solar capturing plant with short-term battery storage and long-term hydrogen storage, which work together to deliver power 24/7. Outside of that, you discussed the black belly sheep. I'm not too a fan of those, but I'm sure who eat mutton would enjoy that, because I'm not a lamb eater. But outside of that, yes, the black belly sheep. And the key thing there that I know persons were interested in hearing were the creation for the opportunity for jobs. So those viewing online, remember you can email us your questions and comments to rsbarbados@hdf-energy.com. And the viewers who are online, on the YouTube live stream can use the chat box to drop any comments to us, and we'll monitor that live and give you some answers at the end of the session. So I'll now hand you over to Justin Jennings Ray, who's the environmental engineer, as I mentioned earlier, and he on with his presentation.
Okay, I prefer to stand. Okay, so welcome everyone to tonight's presentation again on the findings of the ESIA, which is the Environmental and Social Impact Assessment of the proposed photovoltaic energy facility with hydrogen storage at Harrow Plantation in St. Philip. As mentioned, my name is Justin Jennings Ray. I'm a civil and environmental engineer with the Barbados Office of Stantec Consulting. I was part of the team of independent third-party consultants hired by the developer to conduct the ESIA for the project. This involved the receipt of technical information from the developer and the assessment of this information by Stantec and its team. So let me just go here. So the format and the agenda of the presentation is as follows. I'm going to introduce the study team, give a definition of what an environmental and social impact assessment is. I'm going to describe the project, but I will probably move fairly quickly because of the description that Thibaut has given. I'm going to talk about the potential impacts due to the development of concern that were identified by the study, the findings or the results of the study, and then we're going to open the questions to the floor. Okay, so the study was submitted to the Planning and Development Department. I think it was formerly Town and Country Development Planning Office, in the form of a 789-page written report. This required a team effort, so the ESIA team consisted of consultants from Stantec and local sub-consultants. The noise, quantitative risk assessment, ecological assessment, and the actual report generation was done by Stantec staff in Canada. The local Barbados team worked on the drainage study. In terms of our sub-consultants, we have Dr. Janice Cumberbatch, who's a sociologist, and she did the social impact assessment. We have Mr. William Bain, town planning consultant, who did the agricultural impact assessment. So what is an environmental impact assessment and a social impact assessment, and altogether we call it an ESIA. So the EIA, which is the environmental bit, provides information on a proposed development and its likely positive and negative impacts. It recommends measures to reduce or mitigate or lessen the effect of those impacts. On the social side, social impact assessment examines the social consequences, positive and negative, of planned projects. It also recommends measures to eliminate or reduce the impacts as identified. So in other words, it investigates the potential impacts on communities and persons and how to mitigate. So the findings of these studies are used by the planning department, we're going to call the PDD, during their assessment of the project and in defining the environmental protection measures that must be done if the permission is granted for the development. Okay. The ESIA also provides, so it's a guidance to architects and engineers towards the production of environmentally friendly design. So a key point here is that the ESIA is a tool that can be used as guidance to the developer and the facilities designers to ensure that provisions are made in the design, in the design, construction, and operation of the facility to reduce potential environmental and social impacts. Okay, so in terms of the planning application, so the developer, as introduced, is Renewable Barbados, Inc. The planning agent is Richard Gill Associates, represented by Andy Gill here. They prepared the drawings, completed the application forms, etc., produced what you call the terms of reference of the environmental and social study. The application was made on August 2021 to the PDD, and it was termed Installation of a Solar Photovoltaic Energy Generation and Storage Facility with Sheep Farm at Harrow Plantation, St. Philip, Renewable Barbados, Inc., and there you have the reference number. So in response to the application, the Planning and Development Department requested that the environmental and social impact assessment be done. So the items are the contents of the study, had to be discussed with the PDD, so there was a bit of back and forth until there was an agreement on what would be contained inside the ESIA. So after the ESIA was submitted to the planning department and it was reviewed, permission was given by the PDD to make the EIA available to the public and also to advertise and to host this meeting. So, it's just an important point to note that this study has been reviewed by the planning agency in detail and permission has been given. It's been found suitable enough to be presented to the public. So this meeting actually forms part of the planning application process. And as I mentioned, the PDD wants the findings to be presented and a report produced of your comments and any queries that may come up during this meeting. So just to make the point that the developer is still in the permit to construct application stage. It's not advancing. Okay. All right, so as mentioned, the ESIA was presented in the form of a report. Several copies were sent to the planning department, and copies of those documents would have been sent to other agencies such as the Environmental Protection Department, the Ministry of Energy, and so on. Okay, so the document which would have been made available, the content of it, or the table of contents, is as you see there. There's a legal and administrative framework which talks about the laws and so forth that pertain to the development. There's a description of the project which is in the document, energy production and benefits, the description of the environment, so that, we have to let the reader or the regulator understand what the existing environment is in terms of the groundwater, water, air, etc. Then the report delves into the environmental impact assessment and mitigation, social impact, cumulative impacts, so you're looking at other developments which might be going on in parallel and how they may impact on the development and the environment. And then there are what you call monitoring and management plans, which are focused on how do you implement some of these mitigation measures, right? So there were several detailed studies which were done separately. They're shown in the appendices, and the main findings of these studies are actually brought up into the main report. There was a social impact assessment, drainage assessment, acoustic modeling study, which has to do with modeling noise, glint and glare, which is concerned with glare from panels when the sun shines on it, agricultural impact assessment, and a quantitative risk assessment study. Maybe you could advance it for me, somebody. Okay. All right. So, I know Thibault went through the description of the project. I'll try and move fairly quickly. So, as he mentioned, the project will produce non-intermittent, that is constant carbon-free, renewable electrical power, and will also be a black belly sheep farming facility. The power generated is deemed to be capable of powering around 16,000 homes. The electricity will be purchased by Barbados Light and Power. The unit or the facility is expected to be in operation for about 30 years. The development shall be sited on 181 acres of land. So the power shall come from the solar PV photovoltaic panels, which are the blue, the blue squares that you see on the screen there. And these will be fixed to the ground, and they will be or anchored into the ground, and they'll take that. Their total area that they'll take up is around 146 acres. These panels, along with power inverters, will permit the conversion of the sunlight from the sun into electricity. Okay, so what is implied here is that the panels will only produce electricity while the sun is shining, hence the use of the word intermittently, not constantly. So for the Harrow facility, the intent is to use a portion of the power generated from the PV panels to convert water using an electrolyzer, a device called an electrolyzer, into hydrogen and oxygen. The hydrogen will be stored in tanks. Some of this energy will be stored in batteries. The hydrogen, along with oxygen from the air, is then fed into a device called a fuel cell when the need occurs to produce electricity, so that with the energy management system consisting of the hydrogen and the batteries, the facility will be able to produce stable power 24 hours a day, 7 days a week. This energy management system will take up about 4 acres, 6 hectares of land. There are going to be sheep pens, barn for hay storage, a feed silo, water storage tanks, solid waste skip area, farm building facility. These will all take up another 5.7 acres of land. Farming will produce lamb, mutton meat, sheepskin, manure. As Thibault said, there'll be 1,800, or there are proposed to be 1,830 black belly sheep. So there's going to be green space for additional grazing for the areas to grow grass for the sheep. That's going to take up another 25 acres. Right, if you could just go to the next slide for me. Right, good. Right, so just kind of recapping, 56,000 megawatt hour per year facility, 13 megawatts during the day, 3 megawatts at night, solar energy to be used to convert water into hydrogen and energy, for hydrogen for energy storage, and it's going to be a mixed land use development, which is electricity and sheep. Water is required for the production of hydrogen, right? Requires 65 meter cube of water is required daily. This water is also required for the tending of the sheep, and it will be obtained, or shall be obtained, or is proposed to be obtained from the Barbados Water Authority. The developer proposes to construct water storage on site to hold 5 days supply of water for the hydrogen energy storage process. So these tanks will be in the region of 300 meter cube. And this will ensure that there's a consistent supply of water to the process, and the intent is that these will be filled during the non-peak period. All right, I think Thibault mentioned the environmental benefits, so I wouldn't go back over that. If you could go to the next slide for me. Oh, I did it. Okay, if you could go back one for me. Sorry. So, right, so this is the site, shaded in gray, and this image is superimposed on Google Earth, so lots of people who use Google Maps, and so this might be familiar. Let me just come around the front here really quickly. Okay. So what you have here is, that's the boundaries of the site. As you can see, to the direct south, you have Farm Road Terrace and Marchfield Village, which are just on the southern boundary. Here you have 6 roads. Up the top there to the northeast is the Bushy Park Raceway. Padmore Village to the north there. And so the access would be via Highway M and Harrow Road. Okay. The next slide for me. Yeah, you're gonna have to do that for me. Right. I really shouldn't have moved, but okay. So this is the site. This is a site plan or a simplified site plan. So the red line shows the boundary of the site, and if you look to the northeast there, you have the fodder pasture. So that's where the sheep will eat and grass will be grown. There's going to be the sheep farm, which you can see to the south of that, and the admin and offices and storage area. The blue shaded areas there, that shows you the extent of the PV farm. And in the center there is the hydrogen power center where the energy is produced. Go to the next slide. Okay, I really need to let me come again. All right. Hello? Yep. Okay, right. So this is a nice, what you call a 3-dimensional computer generation of what it could look like. So these here, this is looking at the hydrogen power center, and we're looking towards the northeast. So these are the hydrogen tanks, okay? You've got here, I think those are the electrolyzers, okay? These are the fuel cells. These are some cooling units. This is a switchgear area. Over here, these are the batteries, transformers, and the water treatment facility. Okay, so that's the bulk of that. Maybe you go to the next slide. Right. So this is a plan looking up from above. So there you can see the tanks again. We have a look at the batteries here. There's a fire water storage tank there, which is to help with firefighting. And this is a holding tank for, the end product of the treated water. Should not have moved. Okay, so this is a view looking to the southwest, I believe. It's a nice shot. Here you have Bushy Park. You have the fodder area. We have the sheep. That's what the sheep pens will look like. That's a barn for hay storage. That's a farm building, and this will be the offices. And there you can see the rows and rows of panels. Let's go to the next one. Let's see. Okay. All right. So what do these components look like? The fuel cells, the batteries, the electrolyzers. Well, these are proprietary pieces of equipment which will be transported and shall be housed in shipping, what would look like typical 40-foot shipping containers. So if you have an understanding of what a shipping container looks like, that's what it will look like with all of the components and the batteries or whatever within. Go to the next one. Okay. All right, I think I need my notes for this one here. Okay, so Thibault described this process, and I'll just recap it very quickly. You've got the PV plant that will produce the sun's energy, or will use the sun's energy and convert that to electricity. A portion of that energy will be stored in batteries that will be used for short-term power supply during the evening peak hours, right? So that's number 2 that you're seeing there, so that's representing batteries. You have water and electricity going into this electrolyzer to produce oxygen. It's going to then also produce hydrogen, and the hydrogen is stored in the tanks shown at 4. And then when there's a need to produce electricity, you're going to take the hydrogen from those tanks, you're going to take oxygen from the air, run it through this fuel cell, and produce. In response, an acoustic modeling study was done using computer software. As I introduced at the beginning, I pointed out that the expert who did this is from one of Stantec's Canadian offices. And the main findings were that the World Health Organization noise benchmarks are not expected to be exceeded during the day. There would probably be a slight exceedance at night, but this exceedance was not deemed significant enough to warrant, at least in the consultant's perspective, mitigation recommendations. If you could go to the next slide for me, right. So the operation of the facility is expected to release the following emissions to the air. We spoke about some of them earlier. There's pure oxygen from the electrolysis process, hydrogen gas in a controlled manner during the operation and maintenance of the electrolyzers and the fuel cells. Air containing low oxygen will be released during the operation of the fuel cells, and water vapor during the operation of the fuel cells. None of these gaseous emissions are deemed to be non-polluting. If you could go to the next slide for me, please. Right, so for the operations phase, there are negative and positive potential impacts. Noise from the use of vehicles and equipment for farm and facility maintenance, emissions from sheep, noise and carbon, noise from electrical components of the plant was deemed to be potential negative impacts, but a potential positive impact is that the energy generation will be from a non-polluting, carbon-free source. So in terms of summarizing the mitigation measures, again, similar to the construction stage, but this is more in terms of vehicles being used during the operation stage to limit their speed limits and make sure that they're routinely maintained. The consideration of the enclosure of the battery storage facility or physical barriers for the transformers or inverters if there are observed to be noise impacts, and the selection of plant equipment with noise reduction capabilities. All right, so just move on to surface water and groundwater, really focusing on drainage. So one of the key to assessing drainage is actually understanding what is called a watershed, and that's an area within which rain falls and forms runoff that is guided by ridges, slopes of the land to lower lying areas. And this flow can be by overland flow, it can be by natural water courses like gullies, artificial ones like, which people will be familiar with, roadside drains, concrete channel drains, and the use of suck wells is quite common with for drainage in Barbados. So, runoff in the vicinity of these sites, or rainfall in the vicinity of the site and in the watersheds to the north results in rainfall results in runoff, which actually flows from a large watershed to the north of the site towards the site. The site itself generates water, and those waters in combination actually flow through the site and head southwards to the Six Roads, Farm Terrace, etc. Farm Terrace, Marchfield Village area. So there is an existing flooding problem in the Six Road area, as residents of the area would know whenever you have prolonged or intense rainfall. All right, so if you could go to the next slide for me, good. So if you look at the image to the right, there's a blue line and there's some light cyan lines. So what was done was a watershed, which results in water running towards the site, was identified. And as you can see, that there are natural water courses routing runoff in a southeasterly direction. So you could have a look at those blue cyan arrows towards the site, and then southwards to Farm Road Terrace and the Marchfield Village area. Okay, so the development site, which is the proposed site, has been historically used to aid in mitigating drainage problems in the Six Roads area. The site actually has installed about, from existing 23 suck wells, which help with drainage. There is, the site is in what you call the coral region of Barbados, so there is groundwater beneath the site, and it's estimated to flow in a southerly direction. Next slide, please. Right, so interestingly with PV panels, PV farms, is that the panels are actually raised above the ground, and so the grass and the soil, which allow runoff to percolate and infiltrate, remain. So provided the area under the panels remains grass, it's not anticipated that there will be an increase in runoff due to the presence of the PV panels on the farm. The intent of the developer is to keep the existing 23 suck wells and not interfere with their function. For new impermeable surfaces, so when you introduce roads and roofs and so forth, you actually increase the amount of runoff. For new surfaces, there are going to be new buildings, there's going to be the hydrogen power center, car parking areas, and etc. The developer's proposal is to drain these areas on site so that they don't contribute to the runoff that heads off site towards Six Roads and so forth. As shown in this image, so if you look at that image, along the southern boundary of it, highlighted in blue, there's consideration being given to building an infiltration trench to help with the drainage situation. However, preliminary drainage analyses indicate that if you built that device or that swale all along the boundary, you'd only have around a 1.7% reduction in the peak flows. So this is an item which I'm sure the developer will consider further as they do their more detailed drainage study towards design. So the overall intent of the proposed drainage system or the drainage design is to allow the existing drainage scheme to continue and to not make the development add to the storm flows heading southward to Farm Road Terrace and the Marchfield Village area. Next slide, please. Okay. All right, so this is the impact slides, potential impact and mitigation slide of surface water drainage. So as mentioned, hard surfaces, roofs, paved areas, prevent runoff from absorbing into the soil and increase the amount of runoff. So the concern is that the addition of these surfaces as part of the development and also the potential for bare patches underneath the PV panels, that this could cause flooding on site and add to the runoff downstream, increasing runoff downstream to Farm Road Terrace. Also, in the operation of the facility, if there are activities where there are spills and leaks of lubricants and so forth, these could result in these substances falling onto the ground and actually being absorbed with rainfall heading downwards into the soil. So in terms of the potential mitigation measures coming out of the EIA was the maintenance of the existing drainage system. That's paramount as a recommendation. maintaining the grass surface beneath the PVs, making sure that there's an appropriate design done within the project site to drain any additional runoff from the site on site and not let it go off site. In terms of protecting groundwater, there should be regular inspections of septic tanks and soakaways, and there should be proper handling, storage, and disposal of chemicals and fuels. Okay, moving on to flora and fauna. So an ecological study was done on the site for the development to investigate the existing plants and animals and how the development may impact on them. So all of those lines that you see there were walked by our team, and all the various plants and animals and so forth were recorded, okay? And it resulted in, from the perspective of the flora, which is plants, three habitat types, let's put it: cleared agricultural land, grassy areas, and sugarcane fields. In terms of the animals, well, the site is disturbed, right? It's agricultural land, so you know, there were mammals found, birds, and various insects, none of which were considered to be rare or endangered. Similarly, for the flora or the plants found on the property, they were all common species and not considered to be rare or endangered. Next slide, please. So in terms of the operations phase and the potential impacts on plants and animals, the concern would be the impact the development could have on plants and animals. As mentioned, the site is a disturbed site. It was used for agriculture, so there are no rare or endangered species on site. In terms of the recommended mitigation measures, the revegetation of any cleared areas, so this is during the operations phase, the use of vegetation screens to reduce disturbance to animals, the limited use of, or limiting the use of artificial lighting, the use of native plants for landscaping, and the removal and proper disposal of waste. Artificial lighting can attract some nocturnal animals, and the removal of waste will ensure that you won't get rodents and pests. Okay, moving on to the visual. The concern here is the impact on the visual environment due to the development. You're going to see when the development is built, it's going to have panels, it's going to have buildings. These are all objects that can be seen. So the existing environment, as mentioned, is open land for agriculture. The surrounding land use is agricultural and residential. A visual impact survey was done and identified 6 locations where visual impacts may be experienced after the development is built. These are the Harrow Tenantry, Harrow Plantation Yard, Sunbury, Marchfield Village, Farm Road Terrace, and Bushy Park Raceway. Okay, the next slide. So just a couple of pictures here just to give an existing impression of what the site looks like. So as you can see there, this is a view from the Harrow Tenantry looking northeast of the site. And if in the distance, you can actually see Farm Road Terrace, Marchfield Village, the Harrow Plantation Yard. The other picture to the right is from Harrow Plantation, looking to the north of the site, and you could again see the Farm Road Terrace, Marchfield Village. So what this is, at least what the pictures indicate, is that there are clear views across the site to several of the surrounding areas. Another set of pictures looking from Marchfield Village now. So this is looking from the outside the facility, looking back inwards to the facility. So from Marchfield Village to the southwest of the site, you could see the agricultural land, and you can actually see the plantation yard in the distance. From Farm Road Terrace, it's much the same. So there are, what the assessment is showing is that if built just as is, the PV facility would be at least partially visible from all directions. Though there's some existing vegetation which may serve as screens at Bushy Park and at Harrow Plantation Road, these screens do not extend all along the property boundary. Next slide, please. Okay. All right, so another potential impact of PV farms that can affect the visual environment is what is called glint and glare. This is when the sun shines onto the panels, and an example is given in that picture there. So the glint is actually a quick flash, and the glare tends to be a more sustained reflection. So the glint and glare study, which was done, identified 11 points and examined glare at 11 points and 4 public roadways in the vicinity of the site, and looked at 5 different types of panel configurations. The results were that of potential glare at 9 out of 11 points and at 4 roadways. The glare was classified predominantly as green, which is low hazard, or yellow, and was projected to occur very early in the morning after sunrise to the west of the site. Not that the sunrise is to the west, but that's where the glare was, to the west of the site, and early evening before sunset to the east of the site. Next slide, please. So the figure to the right actually shows the property boundary in orange and all the various locations that were assessed for glint and glare. Just a few points about panels generally, that they're actually designed to absorb as much light as possible and really not to reflect. And that glare from panels is generally minimal when compared to other reflective surfaces such as water and steel. So water in the sea or in a pond where the sun is shining on it, or a metal sheeted roof, is estimated to have a much more significant glare than panels. So next. Okay, so coming out of the visual impact assessment was the concern of the visual impact of the development on land users and residents with clear or partial views of the current site, the impact of artificial lighting on residents, especially along the southern boundary, and potential glare impacts, the measures that were recommended in the EIA, and an example is given at the side. There's the planting of thick vegetation tree screen in high impact areas, where possible to limit the use of artificial lighting. Choose a solar panel that minimizes the reflection, and if there's a challenge, remove the offending panels or replace with panels with a lower potential of glare. So I think at this point, it might be Billy. I think you'll go from there. I'll just, yeah.
Okay. Thank you very much, Justin, and good evening to our online and in-person audience. My name is William Bain. I am a town planning consultant, and I was engaged by Stantec to assist with the agricultural impact assessment section of the overall study. So the purpose of an AIA, or an agricultural impact assessment, is to firstly describe the proposed development and contextual factors, determine potential adverse impacts on food and agricultural lands and active agricultural operations on site and adjacent to the site in the surrounding area, and thirdly, to recommend measures to buffer, mitigate, and minimize potential land use conflicts. Now I'll move on to the existing environment. So we know that the site is obviously part of Harrow Plantation, which has an area of 304 acres, with most of the productive lands having been traditionally in sugarcane cultivation. There are currently 252.5 acres in arable production, and the application site will utilise 184 acres. Harrow Plantation is managed by the Barbados Agricultural Management Company from Mount Pleasant Plantation. Now, Mount Pleasant Plantation is located, if I remember correctly, about 3 kilometres. It's about 2 miles, just under 2 miles to the north in the area of Stuart Hill. This information I got from the BAMC, and they've advised that the plantation falls within the agroecological group C. Now, this group is defined by soil type, land capability, that's slope, fertility, drainage, and effective rainfall annual total and distribution within the growing season that meets the need for a specific crop during its growth cycle. Group C is regarded as less productive zone because of the above factors, with effective rainfall ranked highest as the most binding constraint to crop development within the area. And I will mention rainfall a little further on. I seem to have lost a slide. Yes, so I'll move on to the agricultural proposal. The proposed solar photovoltaic energy generation and storage facility will occupy an overall lease area of 182 acres south and east of the plantation yard. The facility will incorporate a sheep farm with a total of 1,830 black belly sheep. Hence, the proposal is for the dual agriculture and renewable energy use of the site. The agricultural component will comprise the following: fodder pasture, or grazing pasture, that's 25.45 acres, and that will be located to the northeast of the solar farm. We saw the image earlier where that would have been identified. Agricultural office and storage facility on 5.63 acres located to the south of the fodder pasture and occupied by 4 sheep pens, a hay storage building, a staff building, and office/storage building. And then we have the solar grazing area. That's the area with the panels, 141.73 acres, taking up the bulk of the application site and providing covered under the solar panels and uncovered grazing areas. It should be noted that there will be no sheep or grazing, or they won't have access to the hydrogen facility containing equipment and system for energy storage. Sheep grazing currently takes place at other solar facilities on the island, most notably at the Light and Power photovoltaic farm in Trents in St. Lucie. Also, you may have seen it if you drive by the facility at Cane Garden near Lester Vaughan School. Sheep graze on that site as well. The figures in the above table demonstrate the shift from solely arable production to arable combined with sheep farming and renewable energy. If you look at the reduction in sugarcane production alone, it's estimated to be just under 90 acres. So these figures showing existing agricultural production are from 2021, and they show the amount of land in sugarcane, 193.75 acres. Sugarcane land that was prepared but not planted, 41.25. Cotton, 17.5 acres, and with a total area of 252.5 acres. And then post-development, it's estimated that 104.5 acres will remain. That's an estimate in sugarcane, because there will be the northern portion of the plantation that will remain in arable production. And then the sheep grazing combined with the solar will be 141.73. The fodder pasture, which we mentioned earlier, at 25.45 acres. The sheep pens at 5.63, giving a total acreage of 277.77 acres. I'll move on to the operations phase now and the impacts on lands of Harrow Plantation. So the total number of sheep that will graze throughout the facility, there's not a range there, it's actual number. The maximum number will be 1,830, with land also being allocated as fodder pasture in the 4 sheep pens that we mentioned earlier, which will also be proposed. Sheep will graze within the solar farm, thereby controlling the growth of grass and weeds. The income derived from selling electricity to the grid will help support the various forms of agriculture at the plantation, and that was mentioned earlier, the introduction. And then it's moving on from that, it's important to recognize that renewables can be integrated with other agricultural uses, thereby increasing the productivity of the landscape. Positive impacts from mixed use with sheep livestock farming, locally harvested meat to boost local meat supplies, byproducts such as leather and manure, and also milk, which was mentioned earlier, and the remaining lands reserved for intensive agriculture. That's the land to the north. The proposed solar photovoltaic energy generation and storage facility will not adversely impact continued agricultural activity. That's the sugarcane production again on the remaining lands. And a local professional consultancy has been engaged to assist in the sheep farm design and management. Again, that was mentioned during the introduction. So the potential impacts that sheep farming can have are overgrazing and pollution resulting from manure. And the recommended mitigation measures that we have identified with regard to overgrazing is that high nutrient grasses will be selected, a rotational grazing plan will be developed, and we'll develop grazing as a service. That's a live mowing service to others. That's where other farmers effectively borrow or rent the sheep, pay a fee for them to control grass growth on off-site fields elsewhere. And with regards to manure management, the majority of the organic load will be generated in confinement. Pens will be raised to facilitate collection of manure, which will be scraped by a mechanical scraper, collected in manure pits, and moved to adequate storage facilities for bagging. And then there will also be an installation of a manure bagging plant on site. And then finally, fertilizer marketing through locally and regionally. And the other point I should mention is that there'll be no slaughtering on site, no animal slaughter on site. Other mitigation measures that we've identified will be the planting of a tree screen along, I've said the western and southern boundaries, but that would have to be looked at of the site to act as a buffer to adjoining agricultural lands. Tree screens are a fairly common mitigation measure used for PV farms. The details of this screen would be submitted under condition of any planning permission granted. And then finally, the plantation should limit the spraying of herbicides on adjoining fields to days that are not windy in order to prevent any dispersion onto the operational renewable energy facility and sheep farm, as well as nearby receptors. I will now hand back to Justin. Thank you.
Yeah, thank you, Billy. Okay, so the EIA also investigated the potential for accidents and malfunctions and how these could impact on the development and the environment. If there is a rupture or leak from batteries or the cylinders or piping, you could get flammable vapors and potentially a fire. A quantitative risk assessment was done to investigate the potential for these hazardous events and the potential these impacts could have on the development and adjacent land use. And coming out of that study was the recommendation of some mitigation measures. Okay. The energy storage system and the associated infrastructure generally should be set back more than 200 meters from the property boundary, so that if there is an event, it is at distance from the nearest adjacent land user. The storage system should be designed to international standards, as indicated there. With respect to the batteries, these should be sealed, in sealed units, as indicated in the container slide that I showed a little earlier. And they should have sufficient fire rating and be able to withstand high temperatures. There should be automated management control systems to shut the batteries down in unsafe working conditions, ventilation system to enable the evacuation of gases and flames, and a fire detection system capable of detecting thermal or gas emissions. Next slide. With respect to the hydrogen energy system, these should also be located in containerized enclosures and sufficiently vented, and they should contain hydrogen gas detectors with the ability to adjust ventilation. Other activities that should be considered, the preparation of an emergency and disaster management plan and the training of the staff and the operators, and also training workshops with the Barbados Fire Service on fighting fires in the energy storage area. Climate change, as I said, it's real. Having constructed the facility should be resilient to climate change and natural disasters. The intensification of droughts could could impact on water supply. Strong tropical storms and hurricanes could damage panels and other infrastructure. So in terms of recommended mitigation systems, ground-mounted systems should be designed to withstand hurricane-force winds. It's been proven that they are made more resilient when you have dual posts. There should be resiliency measures and safety systems in the energy storage center that will allow the facility to continue operation if there's a natural disaster. And there should be further consideration given to using the wastewater from the reverse osmosis system, and also future consideration of rainwater harvesting to offset the potential impact of climate change. To Janice.
Thank you very much, Justin, and good evening to our audience. I am going to go through the social impacts that can be anticipated during the construction and operations phases. Several of these have already been touched on by Thibault. I'm therefore not going to go into excessive detail. Clearly, one of the primary positive impacts at both the construction and operational phases will be job. So you can expect construction-related jobs, and you can expect the spin-off jobs that you get in terms of the suppliers in the construction and renewable energy sectors, and of course the retail business that comes from workers on site purchasing food and other supplies, or people in car rental companies who may get business from this. There are several direct as well as indirect jobs that can accrue. There's, of course, the opportunity for improving the skills and expertise on Barbados as a consequence of this project. So you will expect capacity building for the local workers. There was a specific statement by Thibault that the project is going to target persons within the local community, which implies, therefore, that if the local community does not have the requisite skills, they will be trained and prepared for these jobs. And I've already mentioned the fact that there will be support to the local suppliers and businesses. However, of course, as Justin has already pointed out in his presentation in great detail, we can anticipate noise, dust, and visual impacts by persons who live in the nearby communities. The communities would have been identified on one of the slides earlier. And of course, we would have interviewed a sample of the residents and businesses within all of those communities to get a sense from them on how they felt about the project. Several people, of course, are looking forward to the opportunities, but there are those who are concerned about the potential, maybe visual impacts or the potential accidental occurrences, which we hope would not happen. And Justin, of course, has already identified what is required to reduce the likelihood of this. We therefore anticipate that there will be appropriate health and safety standards within the site to protect both the general public from coming onto the site, perhaps during both construction and operations, as well as ensuring that the workers on the site operate within the highest of construction and operational standards to reduce any potential risk to themselves. There is, of course, also the potential social dynamics that could occur during the construction or indeed operations if you have an influx of temporary workers. But again, we expect this to be minimal because this is meant to be a project that primarily focuses on ensuring that the immediate community is employed in the project, but it of course will benefit the entire island. To ensure that the positive benefits accrue and that the potential negatives are minimized, clearly public awareness campaigns must be undertaken. If people are to get jobs, they have to know when those jobs are available, and they have to know where and when they can apply. I believe that the company has already started with good PR. We have Hake Company here already tonight who has done a lot of work within the community, and I believe employees within the company already have established a relationship with the immediate community that can, of course, broaden to the wider Barbadian public to ensure they have a better understanding of the project. We will anticipate that the company will employ within the requisite legal and labor requirements. Barbados has those regulations in place, and it's anticipated that these will be followed. All of the measures already identified by the engineer, which I do not need to repeat, should be implemented to reduce noise, dust, vibrations, waste, and traffic. And it's anticipated that when this plan is presented and implemented, that the requisite regulatory agencies in Barbados will be monitoring to ensure that they're implemented. We have occupational health and safety regulations in Barbados that should guide how the site is operated, and it's anticipated that the developer, contractors, operators will follow those regulations, and that there will be on-site security at all phases, construction as well as operations, to ensure the public's safety as well as those of the workers on site. We have just 2 more categories, so I'm going to hand back over to the engineer to wrap up the presentation, and then we will open the floor for your questions and answers. We already have a substantial amount of questions online, and I'm sure there's several from the audience here. I know you've heard a lot from us, and it's been a long time, so we are coming to the end of the presentation. Justin?
Yes. Okay, just 2 more sections to go: waste disposal and decommissioning. If you change the slide for me. Right. William went through the agricultural waste already. 1,200 metric tons of sheep manure per year. However, most of this is expected to be collected in the vicinity of the pens by the mechanism that Billy described. No butchering on site, and if there are any dead animals, they'll be disposed at approved facilities. In terms of hazardous waste, you've got the lithium-ion batteries that will have to be replaced from time to time. There's a potassium hydroxide solution that has to be replaced every 10 years, I believe. Oil in electrical transformers has to be disposed. However, note that none of these wastes are process outputs, but will just have to be ultimately disposed of. Next slide, please. So in terms of mitigation, William dealt with that already, in that the manure will be collected and bagged and carried off site. In terms of hazardous waste, there are no recycling or repurposing facilities for batteries in Barbados. So it is anticipated that the batteries are recommended that batteries are exported overseas for recycling. When the potassium hydroxide has to be disposed of, it needs to be done so in a safe manner, and if transported overseas, done in accordance with international waste shipping protocols. And then the transformer oil is recommended that this is collected and disposed of by a specialist waste contractor. Decommissioning refers to what will be done to the facility at the end of its useful life. Would involve the dismantling and removal of the power plant, the panels and foundations, transferring waste to recycling facilities overseas. This is when it is ultimately shut down. There may be the potential that the project, there may be a reapplication, who knows. The regrading of lands and revegetation with natural regrowth. And this decommissioning process could take around 12 months whenever it occurs. In terms of the potential impacts and mitigation, potential impacts are going to be, are expected to be similar as would occur during the construction stage, and those have been dealt with already. They're expected to be short-term, and it's expected that the hydrogen energy storage system should be 100% recyclable. So, just concluding that the design mitigation and protection, environmental protection measures are going to be embodied in an environmental and social management plan, and the intent would be for the developer to implement this plan if a permit is received to proceed with the development. Following this plan would ensure that the developer constructs and operates the facility in an environmentally and socially friendly manner. In terms of the next steps, it's really just to hear from you, to record your queries coming out of from the questions from this meeting. There will be subsequent opportunity for any member of public to raise concerns or queries with the PDD even after this meeting, and then the PDD will review everything, the findings of this meeting, and any other comments, and as they go towards determining the application. Thank you.
Thank you very much, Justin. It was a marathon. And now we get to the fun part where we invite the public to ask questions. I'm sure there are several persons here who want to have queries responded to. So as we're waiting for the first person in or in-person audience to raise a question, I'm going to go to one of the first questions that we have online. And we have a question that says, which I'm going to perhaps offer to Thibault, any alternative feed sources considered in cases of severe drought? So someone's concerned about drought and if there are, alternative feed sources being considered.
Can you hear me well? Yeah. So
this would be for the sheep, I guess, unless it's Billy that's going to answer this one.
you want to take that one, Andy?
Hi, thanks, Thibault. Sure. Hi, I'm Andy Gill from Rushigill Associates. In general, there is the sheep farm has been designed so that there are plenty of grazing areas in and around the panels, as well as a grazing pasture that will be harvested and baled for storage of hay bales for such times when there's a drought. However, if there's an extended drought and the hay bales run out, typically you would source hay bales from elsewhere, or failing that, you would typically supplement the feed by buying bags of feed from a company like Roberts Manufacturing. So that's a typical fallback plan if it is an extended dry season.
On the energy side of the use of the water, because there's agriculture and energy side, we've had consultation with the Barbers Water Authority, and this actual location in the island has a lot of water, right? And the BWA is planning to actually increase the water production in this area. It's already ongoing in terms of planning. And there's almost 70% more capacity than what is already being exploited, that can be exploited in this area. It's an area where some of the aquifer are located, with the northwest as well. So if there's water, supply issue, it's usually more related to a main that would burst, something like this. But and everything related to agriculture was addressed by Andy. We have actually designed the entire project in order to make sure the sheep are always good, and that's why they have additional grazing pasture, and we are storing some additional grass. So in case of a drought, they would not try to basically get the roots out of the soil, or they would not dehydrate at all.
Thank you for that response. So as I'm waiting for an audience member here to make their way to the microphone, we have an in-person question.
Good night.
If you would just state your name.
My name is Julian Rowe. I live in the Farm Road Terrace community. And obviously, I am concerned about the project because when I bought my property, I did not envision that I would be surrounded by a solar farm. And actually looking at the project, it seems like Farm Road Terrace is in the midst of the farm. You can correct me if I'm wrong. Because you're having the panels from the Bushy Park area coming right around the Farm Road area, going right around the Marchfield area, and it seems that Farm Road Terrace is kind of right in the center of it. No? That's why I said, correct me if I'm wrong, because that's what it looks like to me on the chart. So could you put back up the slide with the actual...
Yes.
Thank you.
Keep going. This one here, that
There
one.
we go.
Right. Okay. So
Right.
what's happening
Yes.
is that the Farm Road and Marchfield Village are beyond the south boundary of the site. So it's not it doesn't wrap around the site. It is to the south of the site.
Okay.
And then between the site and the panels, there's buffer land, there's a drainage reserve and other space and so forth. So there's going to be space between the boundary of the site and the boundary where you actually have the first set of panels starting. And as mentioned, a part of the recommended mitigation measure is to actually plant tree screens so that the visual of the site doesn't impact people to the south, to the
But
margin.
what is the actual distance between this first set of panels and then the boundary line for the actual community? What's the distance there?
Don't have the exact. I know for sure there's a 9-meter drainage reserve, but beyond the 9 meter, I'm not sure how far that is. Maybe Andy might
Andy,
know.
if you could just use your microphone.
It's around 50 to 60 feet from the boundary. So here to the back wall would be where the first panels would start. So these panels, the maximum height of the panels are typically around 6 feet high. So they're not like a tall building up in the sky. It's a very low, like the height of a typical human. It would be the typical height of the panels across the land.
Yeah, and yeah, yes. But then the other concern, it is going to be so many panels. And then it's not just the panels, it's the panels with the hydrogen battery. And this is all new too. I know it's new to me. And yes, I've tried to do a little bit of research before the meeting, but I could not find a location to really see like what the fallback has been in terms of if there was any location like this close to houses, because it is close to houses. And then in terms of what problems they encountered, let's say 3 or 4 or 5 years down the line, so you would know exactly what you're up against. Because one of my concerns living in Barbados is this. Everything is presented rosy. Everything is good. Everything is fantastic. Everybody benefits, everybody gets jobs, everything looks good until it does not. And when it does not, there's no way to turn, as you can see from some of the other projects that's happening in Barbados. So I think it is only fair that if a project of this magnitude is coming to an area like this, that we, the residents who have invested a lot of money and who have no plans of moving in 20 or 25 years, which is what I understand is the lifetime of this project, that we are given as much information to work with, and accurate information at that, so that we are able to make informed decisions about our investments, because it will impact us and our grandchildren and down the line. And I heard the information was presented for the 2-year project, which is going to have the noise pollution, challenges with the visual, et cetera, and we are being asked to be uncomfortable for 2 years, because it was like, okay, it'll be 2 years of this, but that's not so bad. It's not going to exceed the WHO standards. But your experience and my experience is going to be different, because I have to live in it. The other thing is this as well. I have not heard anything about when the 20 or the 25 years are up, what's going to happen to the infrastructure? And while the batteries have to be repaired every 10 years, are they going to be staying on site until somebody moves them? All of these little things need to be, information needs to be provided to us. On top of that, I see all of the potential ways to manage all of these possibilities. But who's going to oversee all of this? Who's going to be making sure that all of this maintenance is done? Somebody has to be doing it, and we need to know exactly who is responsible for this project every step of the way. And I've got a lot more concerns, but I'm going to sit down in case somebody else wants to ask a few questions. And I'll leave you a chance to answer some of them. Thank you.
Thank you very, very much. All exceedingly valid concerns. Renewable energy in Barbados is new and increasing. And as we move towards 2030 to be fully renewable, we are going to see more of this. So you have raised valid points that other people in Barbados are going to experience. I'm going to ask Justin to deal with the decommissioning question of what happens at the end. I'm going to answer your question about who is watching to see what's happening. The way this works is that when the recommendations are made and the company starts construction or operations, they're going to be required to implement measures. And then the regulatory agencies, such as the Environmental Protection Department, or the Ministry of Health, or the Ministry of Energy, will be required as part of what you will see in the EIA document to monitor. They will be required to review the reports that the company would prepare in terms of how they're operating. If, for example, during construction, things get out of hand, as can happen, could just be more than you anticipated. There is a project engineer whose job it is to say, stop. This is going too far. We need to fix this before we move forward. Another thing that is frequently required and has been recommended as part of my component to the report is that there be a stakeholder engagement process. There has been a recommendation that there be a stakeholder liaison. That stakeholder liaison could be somebody from within the company, or if there is someone within the community with the requisite skills, that person can be hired. To put it bluntly, that person is expected to slap tar on a regular basis. Communicate with yourself and others as a face in the community. Not a telephone that you call and you get press 1 for this, press 2 for that, and keep pressing, but somebody who is in the community on a regular basis. And if you read the stakeholder engagement component of the recommendations, this is what I recommended. Somebody who's out there to hear the concerns and to bring it back to the operational people to find solutions. This has been implemented in other projects in Barbados where people do go out, do this, receive complaints. Of course, that does not stop you from going on Brass Tacks or Facebook and putting it there, because wherever you want to put your concern, you can put it. The bottom line is that there will be a mechanism in place for you to use, and it is described in the document. The document is online. go and look for the stakeholder engagement plan and the grievance mechanism. You need to read those sections because those sections tell you who are here what you are going to be able to do to contact and relate to the people who are implementing the project. To be very frank, you did not move into, you said you're in farm? You didn't, sorry? Farm Road Terrace, right. You did not move into Farm Road Terrace in St. Philip to see panels. That was not your plan, that was not your expectation. And for many people on our landscape who are living, who have moved out of the town area and moved into or have grown up and lived in these communities for a long time, this is not the visual that you want. No, you've heard that there's going to be screens and trees and all the rest of it, but psychologically, you will know it is there. And I am not downplaying your concern. Your concern is exceedingly valid. But what Justin is trying to offer is the range of solutions, the range of suggestions. And what I am saying is that there's a mechanism for you to keep knocking on Thibault's door and Jacqueline's door to say, I'm not happy, to go to EPD or planning department and say, I'm not happy, and to require them to deal with the fact that you or any of your other community residents are not happy about the situation. So that is written in there. Review it, and if you're concerned about it, there is an email address at the end of the presentation. Send your concerns there, because the Planning Development Department still has the opportunity to require us to make changes in our document to make it more valid and responsive to your concerns. Justin, if you would
Janice, if I may ask a question to simplify, did you not ask the distance from your place where you live? So I think in Bajan terms, when people ask that question, they may want to know, okay, I'm at Princess Margaret. How far down the street is it as far as, say, Shafat in distance? So if we could sort of bring it down a little bit into that layman's terms, because I've been through Farm Road Terrace, and we know that there are houses on the boundary. And there are houses where you come in, and you know there's one way in and one way out. Exactly. So if you're on the main road, closer to the main road, are you on the boundary? And then what do you see? Do you see the back of it? Are you facing this other way? Just out of curiosity. So if it make you a little bit more comfortable, give you the exact distance, not in feet, do it in Bajan terms. How far from here down to Massey, or if they can get a better understanding from Farm Road and the proximity of the actual plant, not the site where the actual plant will be.
Go ahead.
The central facility where the storage will occur is probably 300 to 400 meters away from the edge of where the houses are. So 300 or 400 meters is, just think of a playing field from school when you do your 100-meter sprint. Multiply that 3 or 4 times, and as it is stadium, the straight of a track of a stadium track. It is quite far away. The point though is that because it's in the center, and all the panels are around, that nothing happens around the panel. The panels just sit there silently and make no noise, do nothing. They just sit there and absorb sun. But it is a slightly harder appearance than sugarcane and softer vegetation. So there is a slight change. I think the main mitigation that we do for these solar farms, you put a nice screening hedge around it, which goes quite a ways to mitigate. You put the panels a little further away if it's near to houses, especially because no one wants to be looking right out on a fence. So you kind of give it some space, and then I think the best way to gauge how this will be at the end of the day would be to take a drive up to St. Lucy's Church up by the Trents plant. That's a large utility scale plant, like how this one is, and you can actually drive around the entire back perimeter of the Light and Power Trents plant, anybody can drive around it and look. You can drive right up along the fence, you can look in, you can see the panels, you can listen, you can see what's happening around. You actually can see some sheep on the site. You barely see any sheep because they're so spread out on these large sites that it's rarely a large cluster of sheep unless you're right by the pens. So I would advise anyone who would like to get a feel for how this plant will look. Take a drive up to St. Lucy's Church, go past the church heading north and turn left down the cart track around Transplantation, and you can drive around the entire site and see everything firsthand. So that's my recommendation for anybody who has a question.
Okay. Yes, so in terms of decommissioning, the general intent on decommissioning, which is at the end of the useful life, is that everything goes. So the panels go, the hydrogen center go, the energy center goes, where land has been disturbed is revegetated, etc. So this would be at the very, very end. Now, at 25 years, who knows? There may be a new developer, or the existing developer may apply for a new license. It's unknown. But if at that point the decision is that this is the end of the facility, at least some of the permits that I've seen have basically said that at the end of 25 years, you're to remove everything. Okay, that's what the permits coming from the government of Barbados are currently saying for these types of facilities. So whenever that happens on this site, which is ideally within 25 to 30 years or thereabout, the land would effectively return to how it looks currently.
Can you at the same time also therefore explain the disposal process?
Yes, good point. The panels, as well in the presentation, the recommendation and the understanding is that those panels are going to represent a waste that you can't really reprocess in Barbados, you can't recycle it. So the current methodology is to store the panels, maybe when you have enough that can fill a shipping container, you put them in a shipping container and you export them overseas to a recycler who will actually probably take them and get the valuable components out or remake the panels. So the panels, the intent is not that the panels would remain on island in the landfill or anything like that. The same with batteries. When the batteries are no longer of use, the intent is, or the recommendation and the understanding from the developer is that they will store when it's sufficient to put them in containers, we'll put them in containers and ship them overseas for disposal. That's typically what's done when you have special waste. Right?
Thanks, Justin. So I'm going to pop over to our online audience again, and we have some questions that are all agriculture related. So between Andy and Billy, perhaps we can get some responses. We've got 4 agriculture-related questions, and if anybody in this audience also has agriculture questions, feel free to come up to the microphone because we'll deal with these all together. So one question is that with all the livestock, various vector and disease control will be necessary, and what mitigation measures are in place for vector control. Someone is also asking about the emissions from the sheep, which I'm sure is also one of your concerns. We also have a question about the possibility of overgrazing by the sheep, because the engineer had pointed out that the grass surfaces are a critical component in dealing with the whole addressing flooding and such like. So is it possible that the sheep could overgraze and therefore remove the necessary grasses and therefore lead to more flooding and runoff? And if this has been studied. And then finally, will the manure bagging at the plant be powered by fossil fuels or electricity produced from the solar farm? So vector control, emissions from the sheep, overgrazing of the sheep and the possibility of contributing to increased flooding, and the manure bagging, how is it going to be powered by fossil fuels or the actual solar farm produced energy? You're starting with Jackie wants to respond.
Okay, so my memory is not so great, so let's start from the top, right? The first one is which one?
The first one is vector and disease control. And
Okay.
Jackie, for the purpose of those who missed the introductions at the beginning, just say who you are.
Right, sorry. Hi, Jacqueline Beckles, project manager for this project. So with respect to vector control, the Planning and Development Department actually is very interested in vector control. So one of the things that we specifically commented on for them was how we would go about ensuring that things like rats and rodents would not accumulate on site, etc. And so during the design process, the exact procedures have to be laid out. And so the intention from the very beginning, and the agricultural consultants are working on that right now, is to determine what those processes need to be in order to ensure that vectors are not propagated on site. The other thing, of course, would be to ensure that water accumulation does not occur. Luckily, the ground is very permeable, and also it doesn't, the water raining in St. Philip is generally quite low. So, things like water accumulation tend to be not so much of an issue, but definitely around the farm area, we will be maintaining that and ensuring that that does not occur. Second question?
Then we also have the sheep emissions.
Right. So good to know. Sheep actually emit just around 1/10 of what cattle emits. So the good thing is that the actual GHGs, greenhouse gases, that sheep emits will be considerably lower than any cattle farm. Also, the actual farm, even though it's 1,830 square head, it's actually quite small. So 1/10 plus the size of a relatively small farm in terms of the size of what farms can be, the emissions will not be that high on an annual basis. The good thing about this is that when you generate, when you actually do this locally, when you breed the sheep locally, you don't import anything. You are reducing your GHGs just by the fact that you're not importing anything over marine or air passages. So that ton of carbon dioxide that Thibaut talked about earlier from Paris to Barbados, that doesn't happen. And the additional ton that would probably be generated by shipping lamb from New Zealand to Barbados doesn't happen. So.
Okay, and then your next question is about the overgrazing of the sheep and the potential impact on increased flooding and runoff, and whether it's been studied.
Right. So we have, going back to the fact that we have engaged 2 consultants to study this, we know that overgrazing in any farm in Barbados, you can see it everywhere. We are not just dumping sheep on a site, right? The sheep are going to be farmed sustainably. So with sustainable farming are systems that go along with rotational grazing. And of course, that is along the panels. And then, of course, the fodder pasture is supposed to be for fodder, so there's not going to be a lot of grazing there at all, but the grass will be maintained by cutting and the hay would be stored. So overgrazing, if the rotational system is done right, will not happen, and certainly not over 180 acres, which could be devastating, but the plan is to develop a system that will minimize that.
And finally, the manure bagging plant, how is it being powered?
The manure bag, right. So unfortunately, we can't, technically, I guess we could supply power to the farm from the plant. But unfortunately, in Barbados, you can't really generate your own power. Well, when you generate power, you have to sell it to the grid first. So, power for the plant and power for the farm will come from the grid. So, it is not really possible to say that you can't really assign the green power to any one thing. It will be fed to the grid, and the grid itself will become greener with every green solution that is added to it. That's it.
Thanks, Jackie. Don't sit just yet. I'm going to see if we have any other agricultural comments from the audience here for you. But I do have a comment about the grid that you can mull while we're checking on the agricultural comments. Someone wants to know how much grid upgrade work is necessary.
Okay. So, interesting question. So, the electricity grid is currently under strain because of the amount of intermittent power that is being added to it without a storage solution. So, it is BLPC's role to determine how and when and how much upgrade is needed in order for it to support the incoming intermittent power as well as the amount of power that is being added to the grid. Right now, as a developer, I can't tell you how much work needs to be done, but I can tell you that we are in close contact with BLPC every day, well, every week. And so any work that needs to be done will be done. Okay. So before you sit, seeing how I have other questions online that you can address, I'm going to throw another one at you, and then I will let you sit so someone else from the audience can come up. One of the things that has been pointed out in the early presentation is that there will be jobs. So there's a question here about whether local people will be trained both before and during the establishment of the site for these potential jobs, because they want to avoid, in quotations, the no qualified persons can be found locally, hence persons are being recruited from overseas, close quotation marks. So can you address that as well, please? Right. So there are two things that you could actually see here. Firstly, we've actually already started that process, and one of those guys is actually sitting in this room right now. Both of them are sitting in this room. I'm seeing the other one in the back. So we have actually already started training people for assistance in this project. The EPC contractor will be responsible for the majority of that process. HDF will be responsible for some of it with respect to the preparation of the site, the civil works. And the good thing about the civil works is that a very, very large proportion of it can be done. Local contractors can perform those works. So those local contractors will obviously look within the community, within Six Roads community and outside for local support. The second thing I can say about that is that it will be HGF's role and the HGF's role to set, or should I say, not HGF, Renewable Barbados' role, to set the rules by which the EPC contractor must operate in order to maintain local content. And I can't speak to what those rules will be right now, but I can say that that will be our role.
Thank you very much for your responses so far. Don't go too far. We may have to call you back for further responses. I'm not sure if anyone in the audience has something they want to ask right now. I have a series of questions online about Glinton Glare. There is someone coming up from the back, so let's give him a moment. Good evening. Just tell us who you are and raise your questions and concerns.
All right, good night. My name is Ryan Giddings. All right, my main question is in connection with the water.
Water.
Yes, please. 65 cubic meters of water a day. That's what I was told. That's what I heard. 65? That's what I read. And it seems to be a lot. How many households would that normally serve in terms of the proximity of the location of the site? How many households, on average, do 65 cubic meters of water serve in Barbados?
That's a good question. I wouldn't be able to say exactly how many. Oh, I think Jackie has it, yeah. Yeah, Jackie has it.
Sorry, that's about a medium-sized hotel, and about, I would say annually, it's like 350, yeah, 350 persons.
Persons or households?
Persons, so we can't calculate by household because a household can be multiple people, but we can calculate by capita.
Okay. So a lot of averages, let us know, average Barbadian household with a diminishing population is about 4 persons. All right? So somebody could do the quick math for me there shortly. My concern is that the water mains coming in, are they big enough to supply the project? Would there be infrastructure costs or adjustments has to be made? Which main are we pulling from? And then what are the contingencies? I haven't heard any contingencies in the event of water shortages and stuff, being that we are in a water scarcity environment. I'll respond.
Does it work?
Can I first? As a former employee of the Barbados Water Authority and the former spokesperson, I wanted to address a couple of things. This is a plant no different to Sandy Lane Hotel in terms of its operations, because that's a business, no different to the plant in St. Lucie that produces chicken and uses water, no different to Chickmount, no different to Rubis that would consume water. The whole idea is that we all need water. This plant needs a sufficient amount of water in order to not only produce its needs for energy, but also for the actual plant itself, and then for the sheep, etc. The water is being paid for, obviously, like another business, like any other business. So it's not a case of utilizing water that is going to waste. It is actually going to assist in the production of renewable energy. So when we ask how much water we use, then we can start comparing every business in Barbados to see how much water is actually being used. It's when we misuse water, then it becomes a problem. But the actual proper use of water in order to produce such a plant and produce not only the black belly sheep, but the energy that is required as we're working towards 2030, 2035 now, I understand from the Prime Minister, towards lowering our carbon emissions, I think that you have to look at the balance and to see the benefits as opposed to just seeing it as a lot of water. That's just my opinion.
All right, a second, please. I was told that, let me say that you'll be paying for the water. There's no cost, you can't pay for water. Especially when you can use the water, then it could be scarcity of water. No matter how much money that you pay, there's no water. My concern is that I see there's only 5 days of water harvesting for the plant. Haven't heard anything about any dams being built and stuff to facilitate the farming. What's more concerning is 5 days of storage. It seems nominal given the fact of the demand in the plant, given the fact of our water scarcity situation. And then in the study, which is very important, MSA said, the trade-off of water versus emissions. Yeah? We can live with pollution a little longer. We can't live without water. So is there any plans, any mechanisms in place in terms of facilitating and helping the community to do a more domestic water harvesting per household, which we in Barbados currently, we're not very efficient in terms of water harvesting at that level. Is there any level of investment being put in place to facilitate at the community level? Water harvesting programs, training, anything of that nature, because this is going to be a major issue without a doubt. No matter how much amount of money we put in the project, we can't pay for water. There's no cost attached to water. You pay for the service to provide the water. So how do we go about doing this in a more strategic manner? I haven't seen anything in the document that speaks to this. Could somebody please help me to understand that? There's one more question. And then also, excuse me, a project this magnitude, just looking at the basic numbers, could be well up in the hundreds of millions. Have not seen anything in place. Does the community have the opportunity then to invest and get a return on the project since you're coming into our space and inconveniencing us? Is there any mechanisms in place that John Brown, Mary, June could invest in the project and get a return on investment?
So I would take the last question related to investment.
Yes, please.
For the water, just the tanks is, you right, 5 days, and this doesn't mean that we have actually been meeting a lot with the BWA in terms of capacity, but also the fact that we can, so whenever there's water scarcity or whatever, we can actually decide with the BWA to take water at some moment and some not, thanks to this buffer. I wanted to just add this. But related to the investment,
Right.
yeah, so related to the investment, I mentioned at the very beginning that the intention from HDF, which is one of the equity investors, 49%, is to sell down 30% to the, so I touch base on the credit union movement. So actually the discussion that are being held right now is with the Pablo Sustainable Energy Cooperative, right? And this is a movement that actually, this is a pocket that taps into credit unions, and credit unions right now have addressed more than 200,000 Barbadian on island. So this is the mechanism that we found the best in order to have this opportunity for return on investment at the community level, right? So right now, we haven't implemented the mechanism specifically for Sixth Road, but it's at the credit union movement. I think the credit union movement is represented as well here, so maybe they can speak to it as well.
Okay.
Yeah.
Yeah, but so we just have some information for you regarding the water, a little bit more accurate, about 70 households we're looking at, and that's 250 gallons per day on average. So I just trying to figure out whether you think that it's abuse of water, waste of water, because it's being utilized for good reasons.
Right, but there's a trade-off. There must be a mathematical calculation to this.
But
emissions-
also understand, Mr. Giddens, that the water is not constantly running all day long for 65 gallons, 65 cubic meters.
But it's still 65 cubic meters of water.
But it's still going to be stored, and there's also going to be half of that is going to then go back and to be reused, about 30 cubic meters of water that Jackie can then explain that. I guess what I'm trying to say is if a hotel the size of Sandy Lane decided they wanted to come into Six Roads, what would be the discussion that is you're using water because human beings are there. So you have to use water. A plant is being set up. They're paying for the water to bring it to good use so that we can have renewable energy. And when we talk about things, the reason why we may have these droughts is because of the carbon emissions, or all of these things that are polluting the atmosphere. If we can reduce that, we have chances of better rainfall, not long droughts, or should I say storms, etc., and Category 5 hurricanes. The reason for this is because we are under attack with climate change, with the very practices that we are doing as human beings. We have to put things in place in order to mitigate that. Not only about just lowering the energy costs, or should I say stabilizing it, that's part of it, but lowering the use or reducing the use of fossil fuels is extremely important, and it has a direct impact on the water supply, because it is actually that emission that is sort of messing up the rainfall and the consistency or lack thereof right across the world.
Right, but I think you misunderstand. I mean, my concern is the harvesting. I don't think you all have enough mechanisms in place to facilitate proper harvesting.
I can,
Right?
I might not
my
be.
concern.
Good points. Very good points. I totally are on board with them. So I'm not gonna answer a question completely because I don't know. I'm pretty sure I can't answer it completely. But the points I would say would be these. Yes, it's 70 households using 250 gallons a day. That's like 70 houses, which will be a part of, I guess it would be a fraction of the community down south, but still significant, 70 houses. But the mitigation that I can think of would be firstly the fact that we're likely to put more suck wells eventually all around the site. It'll increase the infiltration of rainwater. which will add to the groundwater reserves, which means that we'll be able to pump more in the future. So it'll contribute towards that. We also will mitigate with trickle feeding these 5-day tanks at night. In other words, you won't want to try and fill the tank during the day when everyone's using the water. So it would be a trickle feed mechanism so that they're topped up gradually at night, so that they don't impact the community. And there is rainwater storage. All the sheep pens, all the buildings, etc., are storing all the rainwater from the roofs, putting them in tanks, and reusing them to help water the sheep, etc. So they're doing as much of that as they can, given the limited amount of roofs, etc. But all of the depressions and ponds across the site, they're not ponds, the dry depressions, all of those are likely to have additional sat wells to help put more water in the ground, etc.
Right.
But that's not going to answer your question.
Well, you already answered it, but how much sat wells we getting, how fast we getting them?
Right, well, as a
Engineers
would
water.
detail that.
We can play with anything else. Pollution can be here today every day, and we can get more pollution, but
We're water scarce. We're a water scarce country.
Right. And the earth is struggling already with enough water issues. I mean, say draw a valid point in reference to the effects, right, of the emissions and stuff, which I agree. However, tomorrow morning when we wake up, you must have water. That's all I'm saying. So how do we go about it? Is there we're spending 207 million, how much ever million? I want to see some activity in the community. Are we coming and saying, look, we are going to put 100 tanks in the community in the event? How are y'all doing this?
It's actually...
Can I respond?
Yes, please.
I don't think that we can reasonably expect a response to everything tonight, but I think what you have done is made some valid recommendations that we can take up.
Right.
And Jackie also has some more to add as the project manager. But I think your point, for example, about enhancing Barbadians' involvement in increased rainwater harvesting, which is not happening sufficiently, is an important point. If we could let Jackie, because the other issue we have, she wants to respond, and I also want to see if we can get a few more people to come up to the microphone as well. Jackie?
Okay, so with respect to water, that's a really, really important question. So the process itself takes 65 cubic meters a day. That is true. 60 of it goes towards hydrogen production, 5, we anticipate around 5 goes to the farm. However, it's a really, really important point to highlight that the 60 cubic meters that goes towards generating hydrogen actually discharges about half of that into the holding ponds that you saw in the plan picture for use elsewhere into the site. And the reason why that happens is because the process of generating hydrogen requires pure water. So whatever comes into the system has to be purified by the water treatment facility before it goes into the electrolyzers. And when that treatment process happens, half of it is discharged. And that half is put into a holding pond, at which point we test it to make sure that to find out what the mineral content will be. And once we are okay that it can be reused, it will go towards things like irrigation, like panel wash down, because of course the panels will have to be kept clean. It will go towards the farm and cleaning the farm. It will go towards, maintaining the site in a general way. So you can actually see that half of the water that we are using in the process is reused. The second point that is very important to note is that we are studying right now rainfall harvesting. There is a study going on by Alan Armstrong, which is a local contractor, that is studying both drainage and rainfall harvesting. And the rainfall harvesting we have roofs, depends, we have the administrative building, and 1 or 2 other small buildings that we can study, but we will have harvested water that we can use for other purposes. And I think the last thing I would like to say about that is and it's really important, the Alan Armstrong, on top of the rainfall, as I said, is looking at drainage. And drainage in St. Philip is an issue, especially in the Six Roads area. We've identified that issue. Justin has pointed out, has made recommendations, mitigation recommendations in the ESIA. So anybody who's interested can take a look at the drainage study. And Alan Armstrong is studying how the site, we can ensure that any works that we do on the site do not negatively affect the downstream population. So, and again, Alan Armstrong is a local contractor. So I can even see in this short time that we've generated quite a bit of work for local contractors just in the studies that we are performing to ensure that these things are adequately addressed.
Thank you, Jackie. I forgot one thing. This is our first hydrogen project in Barbados, correct? Right, so what model are we using from what country? What other projects can we look at? I haven't seen anything in the document to give me a cross-reference. So I need some help on that so I can do some proper reading and stuff on what's happening.
Can you hear me? So, yeah, so basically the hydrogen, so as I said at the very beginning, this is of course new to Barbados, especially the way to produce the hydrogen right now. Especially as Barbados doesn't have any industrial facility using hydrogen, but what you need to know is that hydrogen is being used in huge quantities all across the globe with safety measures, with tested equipment over like decades and decades. I can quote a few industries that are using that, and I can quote like another territory where we're operating that has been using that next door, which is Trinidad and Tobago. So basically every ammonia plant, methanol plant, steel plant, every refinery, every urea plant are using hydrogen everywhere in the world at very large quantities. This is a very small quantity. Just to give you a comparison, this plant will generate green hydrogen, 600 tons per year, so never more than 5 metric tons would be stored in this container. Basically, Trinidad, on a yearly basis, produces 2 million tons of hydrogen at Point Lisa Estate to produce a lot of things with a very good track record. In terms of producing hydrogen with electrolyzers, this has been implemented. A similar project is under construction in French Guiana at the moment. There's multiple, more than, the same size of electrolyzer that have been implemented around the world and works with the world standard safety measure. But again, the key point is not to see hydrogen as a new thing, it's just producing it in a clean way is the new element of it. This is being produced in huge amount all across the globe, but out of gas, which is related to global emissions.
So what model are we using again? Which country model are we using again?
Trinidad and Tobago.
Using Trinidad's model?
Sorry?
Whose model are we using again?
Whose model?
The standards for safety. So
Safety, implementation, infrastructure, everything.
So for this project, the US standards are being used. For the design, we started with the European standards and then we switched to the US standards based on recommendation from Stantec.
Okay. One of the things that you can actually do is go to their website, because renewstablebarbados.com, the regional references actually lists all of the other countries where they're working and the procedures that they're using. But that was not enough information then. No. Fair enough. Thank you. We have a few more questions online about glint and glare, which I'm going to raise now, and I'll give the audience an opportunity to raise additional comments. We are half hour beyond when we told the school we would be leaving, but I think it's a really important opportunity for people to ask their questions. As far as glint and glare is concerned, we have questions about how long is the glare expected to last during the times that were identified, Justin, this would be one for you. There's also been a question about investigation being done on the actual effect on the nearby developments, especially given the height of the PVs and the distance from the southernmost community. And finally, the potential impact on the visibility of drivers on nearby roads. So I know you did cover some of these, but obviously people come at different times. So if you could just address the how long it's expected to last, the impacts on nearby residents, especially the southernmost community, and visibility of drivers.
Right. Let's see now. Right, you wanted to know how long. If you could just go back to that slide there. Right. Right. So there were. So what happens when you do the assessment is that the software, let's put it this way, doesn't take into consideration natural boundaries, you see. So when the software says that you're going to have a glare impact, it is assuming that there is actually no barrier between the panel and the receptor, okay? So what's going to happen is that the software actually models the movement of the sun over 365 days of the year. And it's basically saying that when you do have glare, it will happen very, very early in the morning or very, very late in the evening, okay? So there is going to be, or I can't say there's going to be, but the model predicts that there is the potential for glare, and coming out of that is the recommendation that there is a barrier put up. So this barrier would be a vegetated screen. So the intent is that this vegetated screen would actually go around the site and will basically block all of the partial visible areas of the site. So where partially the site can be seen from the various vantage points, including the roadways, including the some of the residences, especially to the south, there will be a barrier so that the impact of the glare is, or the potential impact of the glare is not seen.
Thanks. I know there are at least two members of the audience who want to comment, Mr. Hutchinson, and then our resident from three and one more at the back. So Mr. Hutchinson started coming up before. Yes, please.
Could you go back?
To which slide?
The slide showing the site plan with the boundaries. You want the earlier slides. Yep, that one, yeah. I'll show you, this is the train line, now called the trailway. To what extent is it goes through the project, so what extent is the use of the trailway compromised by the project?
It's actually not. Why don't we just give Jackie one of the microphones?
Okay, you could, okay.
Good question. So we've actually been in touch with Barney Gibb about assisting with that project. We are not intending to design over it. We're intending to see what we can do to help him develop it. Nothing has been decided yet, but definitely it will be, it will not be affected by this project.
Not
That's the intention.
compromised. Yeah.
Correct.
So, thanks. Earlier you spoke about water, and I think you said 15,000 gallons a day, approx. But you also said in one of your slides that the process produces water in going from hydrogen. So would it not be better to speak about the net water demand? 15 is what goes in, but you're going to win back some, presumably. So is it not better? How much is, I'm trying to find out what is the net water demand. The 15 is the gross, but if you have the opportunity to reuse, there got to be a. How much is the net? How much is recovered from the recycle?
So the calculation, I could provide that for you.
No, I just want a number.
It's an answer that I would have to research.
Okay, you're not sure. Right.
Basically, the water, so the fuel cell reproduces water. Part of it, because of the temperature of the chemical process, part of it just becomes steam, and a part of it is recirculated. But this is true, we produce pure H2O, pure water with no minerals that comes out of it. But we have all those calculations, and that has been looked at.
But
in the ESA.
Can you reuse the water, or is it considered a waste?
No, it's being recirculated.
Right.
But it's part of it only.
Right.
Because a part of it is steam, right?
Right.
Some of it that is actually recycled in the fuel cell process. I don't know what the exact number is, but
yeah. So the other thing I want to share with you is just an observation of mine. I live in St. Philip all my life, and I've done a few projects around here, and in the 80s, 1980s, there was an unusual rainfall event that there's the watershed which comes across the site. It's about 1,400 acres. And in 1983, I think it was, there was precipitation over the whole area, and there was an extreme flow that came right down through. And you see it there. I think that watershed flows across the site. And I'm just saying, I'm not trying to be negative, I'm just saying based on my experience, the frequency of flooding is very rare. It will probably take like a 1 in 50-year event to have that, to get a flood from that watershed. But with the size of investment that you have, I think it's desirable that you think about it, because a 1 in 50-year event going across the site may have a significant impact on your investment. All right? Of course, in 1983, when it flooded, it also came through Farm Terrace, ended up through Industrial Park, and ended up in what is now Emerald City. It's going to happen again, but it's a rare event. So most people, there are probably many people living today don't even know about it. Younger people. You know about it. Okay, so she's old enough to know about it. And I'm saying, right. So I'm just saying, from a drainage perspective, we talk about cyclical events that happen 1 in 10 years, 1 in 25, 1 in 50, right? Now, the nature of that watershed is not going to flow frequently, but it's going to flow maybe. I did analyze it for a legal case already, but I don't remember right here. But it's probably like a 30 or 40-year return period. But it's not if, it's going to happen again. So I'm just saying that it's advisable that the project understand that and mitigate that as far as possible, right? Both in the interest of the project and in the interest of the people downstream, like the lady in Farm, right? Is Farm View? Right. So there are my comments.
Thank you very much, Mr. Hutchinson. There is a gentleman at the back who hasn't had a chance to speak as yet. You had your hand up. If you would come and raise your questions or your comments. Yes, you have to use the microphone. And then the resident from before. And I must say that after that, we do have to wrap up, because we have the people at the school who are waiting now to close up.
Just wanted a little clarification on the capacity of the plant, because we heard that it was a 13 megawatt base load plant, but yet during the night it is 3 megawatts you're producing during the night. Well, in power generation terms, then it couldn't be a 13 megawatt base load. You have a total of 13 megawatts installed?
So we have way more than that. There's 50 megawatts of solar.
Sorry, how many?
50 solar installed and 120 megawatt hour of storage. Basically, when you...
So 50 megawatts in total?
50 megawatt of solar and 120 megawatt...
Sorry, that's 50 you're talking?
50.
Yeah, okay.
And 120 megawatt hour of storage. 120 megawatt hour. So that's an energy unit, and the 50 megawatt is a power unit, right? So when you install 1 megawatt of solar, you only produce, you multiply that what we call a capacity factor, which reflects how much you can produce out of the solar. In Barbados, with the good sun resources that there is, you produce actually 22% of this maximum power, because the sun is shining only 8 hours during the day. So you need to over-install capacity in order to be able to store and make it a baseload plant.
Yeah, I understand that. But my question is, what is the capacity that you can supply to the grid during the night? 3
So
megawatt?
there's 2 levels. There's a 3 megawatt during the entire night, and there's 2 hours at 13 megawatt that can be called by the grid whenever it's the most valuable for them. The 2 hours at 13 megawatt are going to be dispatched most probably at the end of the day peak, when it's the most needed for the grid. And no solar can produce power. And 3 megawatt is during the day, the night.
I think I got that, but I'm just saying that in power generation terms, if you have only 3 megawatts continuously during the night, then the maximum that you can say it is in terms of base load would be 3 megawatts. Because the base load, in terms of power generation, I'm not sure what industry you're relating to if you're talking, but in power generation, you could not call that a 13 megawatt base load plant.
Okay, so it's a 13 during the day and at the end of the day peak for 2 hours base load, and a 3 megawatt base load during the night. That's what was presented with the power service.
Right, but in the power generation
Okay,
industry.
so we won't call it a 13 megawatt
base
base load.
load is like what you have running continuously to meet both the minimum load that you have and then the peaking plant goes on top.
Exactly,
So,
correct,
anyway,
you're correct.
I understand, but just to clear up that.
Ma'am?
I just have 3 questions. One, in terms of the information presented tonight, is this information going to be made available to the community? Could I see this document so I can read it at my leisure?
So the EA is already on the website. The report that is being prepared from all of this is going to be an annex to that report, and it will also be uploaded to the website.
Okay, so I can have access to
So
that
yes.
too. In terms of the actual project now, there's going to be a lot of heavy equipment on our pathetic roads because the roads are bad. So how are you going to then contribute towards fixing the roads? Because obviously that's going to cause some destruction and we need to have a road to drive on.
I can also answer that. So for developments of this nature, there is a requirement that the contractor will return the roads to not the pathetic level that they're at now, but improved levels. So given the state of the roads now, and yes, we understand that the roads will further deteriorate, the expectation is that there is going to be a requirement, and that will be written into the conditions that the roads be returned. That will be a condition.
Okay.
That's 2.
Thank you. And the third question is this. I understand that, yes, this project is going to generate jobs, but what other areas will it actually contribute towards the communities that are in close proximity to the project? Are you going to come on board and work with us as well in terms of helping us to develop some of the other projects that we may have planned?
I'm not going to speak on behalf of the developer,
Somebody's
but
gonna
I'm
say
going to
yes,
ask the developer to answer.
I'll answer that. So instead of the developer trying to invent what the community likes or wants or have issues with, we decided to contract with a communication agency to find out what was the need of the community. I believe I'm not wrong when I say jobs was a concern, roads was a concern, and the other point that the gentleman, I don't remember your name, sorry, raised about water, rainwater harvesting was another point that was raised. So instead of doing hypothesis about what Six Road needs, we decided to have a survey being done and collect those data. So we're going to process this data and come up with a plan in order to see what we can do, what we cannot do, what we can improve within the community. So that, and just so you understand, this is project development. So right now, the companies, Rubis and HDF, which are financing this development at risk, are actually expending money in order to hire people, to hire consultants and so on, in order to try to make the development the best way as possible. So we are actually putting money on the table to understand better the concern, hence why we are trying to have this nice public meeting as well, to engage as well as possible and come up with a plan that comes from the concerns and not from the head of the developer that has really not the understanding of the everyday life of locally. So those things are being heard and have been collected, and this is why as well we said we have access to communication with the community in order to see what can be done. Realistically, what can be done. Roads, for example, this is something that can be done, can be a requirement and so on. Rainwater harvesting, we started discussing it. I can't tell you what is the plan right now, but we started discussing it. We came up with ideas that actually were our ideas, and it was not really reflective of what the community needed. So this is really what we are doing at the moment.
If I could add to what Thibault is saying, because we went out in the community, this is a good opportunity over maybe the next 7 days for those of you watching who did not fill out that little survey, and we probably don't want to use the word survey these days, but that little questionnaire. It was about your knowledge of energy, and the questionnaire actually asks what would you like to see improved in your community, and roads actually was a major thing. Of course, one person talked about their home. People had their different things, but the number one thing we saw was roads. Of course, people want jobs. People talked about the park that's on the main road, or like a resource center for the children. People talked about access to Wi-Fi. So there are different responses, and I must take the opportunity now to thank those who participated in the questionnaire. There were over 100 of persons, maybe with 300 and something houses, which was not bad when you think it came on the heels of another survey that people were a little bit standoffish, so they still participated. So I want to take the opportunity to thank them for participating, but to also say over the next 7 days, if you want to, if you haven't filled out the survey, be more than happy to come back out to those of you who are not at home and to fill it out so that we can get a better idea as to what the majority of the community would like to see improved.
Okay, thank you.
Thank you as well. Let me take this opportunity to thank the audience online for their questions and for staying with us. I believe at one point we had 32 people online. And of course, those of you who are here tonight, I can see that some people have come directly from work. So this is an important issue to you, and you may or may not have actually had supper, so you're probably pretty tired. But we really appreciate the input. Not only have you raised questions that we could respond to, but you've raised questions that we may have to reflect on a little bit and make slight changes to what we've done so far. I've put back up our closing slide, which gives the address of the email address of the lead engineer on the project, on the EIA, so that if you have additional questions or comments that you were not able to get addressed tonight, please send them along and you will get a response. So again, thank you to all of you who have come out. Please, as Joanne has said, fill out the questionnaire so that we can get that information which will serve to improve what can be done in your community and how the developer can work with you as a new neighbor in the neighborhood. Do be safe, get home safely. I've been given a note. What is that note? Oh, I've been told that you can also go to, pay attention, RS Barbados, so Renew Stable, RS Barbados, that's not hard to remember, at hdf.energy.com. RS Barbados at hdf-energy.com. So if you want to know what it is, anybody up here can tell you in case you missed it, but you can send comments to Justin or to RS Barbados at hdf-energy.com. Travel safely and good night.